Earthing requirement for emergency diesel generator. Enhanced guide. Earthing, or grounding, is a critical safety feature for emergency diesel generators, ensuring protection against electric shocks, equipment damage, and fire hazards. It provides a safe path for fault currents to dissipate, maintaining system integrity and safeguarding personnel. The standard requirements include generator neutral earthing. The neutral point of the generator must be effectively earthed to ensure fault current has a safe, low-impedance path to the ground. This is crucial for the operation of protective devices, e.g., circuit breakers, during earth faults, allowing them to trip rapidly and isolate the faulty section. Impedance earthed. Connection through a resistor or reactor, e.g., low resistance earthing, LRE, high resistance earthing, HRE, often used to limit fault currents and transient overvoltages, especially in larger systems. This can be a key consideration depending on the generator's size and system type. Dedicated versus common earthing system. Emergency generators typically require a dedicated earthing system, separate from the main supply earth, especially when operating in isolation, standalone mode. This prevents fault currents from the generator from affecting the main electrical system and vice versa, ensuring selective fault clearance. In some installations, especially where the generator is permanently connected to the main switchboard and operates in parallel with the utility, e.g., seamless transfer systems, a common earthing system might be permissible, provided the design ensures proper fault discrimination and safety under all operating conditions. This requires careful consideration and adherence to specific standards. Earth electrode resistance. The resistance of the earthing system should generally be less than 1 ohm. However, some standards allow up to 5 ohms for smaller installations or in locations with high soil resistivity, provided the overall system design ensures adequate fault clearance and touch voltage limits are met. Emphasize that the specific value is often dictated by local regulations and the type of earthing system. Also, mention the importance of regular testing to ensure the resistance remains within acceptable limits. Multiple earth pits and electrodes. Install multiple earth pits, 2 or more, interconnected for redundancy and to achieve lower overall earth resistance. Use GI, galvanized iron, or copper earth electrodes of appropriate size, length, and depth as per design calculations and soil conditions. Redundancy. If one pit fails, others still provide a path, lower overall resistance, parallel paths, and better dissipation of fault currents. Mention that the spacing between pits is also critical for effectiveness. Body, frame, earthing. The generator frame, engine block, alternator casing, control panel, fuel tank, and all other non-current carrying metallic parts of the generator set must be effectively earthed separately to protect against leakage currents, insulation failures, or faults within the generator. This ensures that these accessible metallic parts do not become live under fault conditions. Compliance with standards. Earthing must strictly comply with local and international regulations such as IS 3043, Code of Practice for Earthing, India, IEEE STD 80, Guide for Safety in AC Substation Grounding, NEFPA 17 NEC, National Electrical Code, USA, BS 7671, Requirements for Electrical Installations, UK, or other relevant national and regional standards. Always consult the specific standards applicable to your jurisdiction. Lightning protection. In outdoor or rooftop installations, include a comprehensive lightning protection system, LPS, in accordance with relevant standards, e.g., IEC 62305 series. The lightning arresters, or air termination network, must be robustly connected to the earthing system to safely dissipate lightning strike energy, protecting both the generator and associated electrical equipment from direct and indirect lightning effects. Regular maintenance and testing. This is a crucial missing point. Emphasize the need for regular visual inspections of earthing connections, continuity checks, and periodic earth resistance testing, e.g., using a full-off potential method, to ensure the integrity and effectiveness of the earthing system over time. Environmental factors, soil conditions, and corrosion can degrade earthing performance. Clear labeling. All earthing connections and earth pits should be clearly labeled for identification and maintenance purposes. Conclusion. Proper earthing is paramount for ensuring both personnel safety and the longevity of equipment in emergency power systems. It is not merely a compliance requirement but a fundamental aspect of a robust and safe electrical installation. A well-designed and maintained earthing system significantly reduces risks associated with electrical faults and external disturbances.